This is chemistry, continuing our discussion on equilibrium. So here I'd like to show you how to determine concentration. So let's take a look at the first example. It says, what is the concentration of H3O plus or hydronium if the concentration of OH minus or hydroxide is 2.7 times 10 to the minus fourth molarity? So how do you figure this out? What are you supposed to use? Well, for every example in this lecture, we're going to use this equation. So it's the Kw, or equilibrium constant for water, which equals the concentration of H3O plus times the concentration of OH minus. So how do you fill this in now? Well, the first thing I'd like to remind you is that the Kw does have a set value, and that's not going to change. So this you will always know. So what I will ask you is to figure out one of the other two concentrations. So that means I have to give you some value in this problem, which I did. So I gave you the OH minus, or the hydroxide concentration, as 2.7 times 10 to the minus fourth molarity. So you now know 2 out of the 3 variables. So it looks like this. So Kw is a set value. That is always 1.0 times 10 to the minus 14th molarity. The strength of hydronium, or H3O plus, is what we're looking for, and the strength or concentration of OH minus was provided, 2.7 times 10 to the minus fourth molarity. I know some of you immediately can just solve for the H3O plus, but some of you need this step by step, so I'd like to go through this. So we are trying to isolate the H3O plus, that's what we're looking for. So the 2.7 times 10 to the minus fourth needed to be moved to the other side. Since these two are multiplied, the way to remove it is to divide. And now what I'd like to remind you, when you type this into your calculator, please make sure you are typing now 1.0 EE to the minus 14th. We learned that a long time ago when dealing with exponents. If you put in times 10, it doesn't always provide you with the correct calculation, especially when you are multiplying and dividing. So please use the EE key. So to plug this into the calculator, it's 1.0, hit the EE key to the negative 14, then hit divide, 2.7, the EE key to the minus fourth, and this is your answer. Whether or not you use parentheses is up to you, but it should still work as long as you are using the EE key. Okay. Next one. What is the concentration of hydroxide, or OH minus, if 7.6 times 10 to the minus second molarity of HNO3 is dissolved in water? So again, we are using the equilibrium constant equation here. Kw is a set value. So what do you have now in the problem? Well, it's asking, what is the OH minus? So you are looking for the OH minus. So that means, even though it's not stated up here, that the 7.6 times 10 to the minus second molarity is the H3O plus. So if you're looking for the OH minus, then this value has to be the H3O plus. And it is. So here's how you plug it in. So you are trying to isolate the OH minus, that's what you are looking for. So you need to divide by the 7.6 times 10 to the minus second. And again, when you type this into your calculator, make sure you are typing 1.0, the EE key to the minus 14th, divided by 7.6, the EE key to the minus second. And this is your answer. Okay, one more. And here's where you need to be careful now, but I'm pointing this out for those of you that might be headed towards AP Chem or more classes in science. There's a reason for everything that I'm teaching you, because that knowledge does come up in further examples. And this is the case right here. So you might notice that I put H2SO4 in red. So I haven't really been mentioning like this HNO3, that's nitric acid. And then up here, I didn't really mention an acid or a base, but the more I teach you examples here, I'd like to go through a couple other details that you just might encounter later. Okay, so what you should notice is that this is H2SO4, that is sulfuric acid, but up here we had HNO3. So why am I pointing this out? Well, we'll get to that in a second. Let's just set up the problem like we usually do, and then notice what that H2SO4 has to do with it. So I'm asking, what is the OH minus if 0.16 molar H2SO4 is dissolved in pure water? So it's the same equation. Kw is known. So which of these two did I provide? Well, I'm asking what is the OH minus, so this 0.16 molarity must be the H3O plus, and it is. But I am now pointing out that you are using H2SO4. Earlier in our lectures, I pointed out to you that that's called a diprotic acid. So it can actually donate 2 protons. So that means that this 0.16 molarity needs to be doubled because this is a diprotic acid. So if you look back in my example here, this is HNO3. This is a monoprotic acid. So I did not need to double the concentration. But if you have a diprotic acid, you need to multiply this by 2. If you have a triprotic acid, you would need to multiply by 3. So that's just a little detail to pay attention to, and I wanted to make sure you were aware of it. But now the math remains the same. You're trying to isolate the OH minus, so you need to divide. And again, when you type this into your calculator, it's 1.0, the EET to the minus 14th, and then just divide by 0.32. And this is your answer. And don't forget, for each of these, the unit is M for molarity, because that means strength or concentration.